Hello, this is Rukmani Devi. Now we are going to see Unit 4 Power Estimation. How the power can be estimated in VLSI. That we are going to discuss here. The introductory part. Average power estimation involves accurately estimating the average switched capacitances at the internal nodes of a circuit. Why estimate power dissipation? Accurate power estimation is critical to IC design. Total power consumption must be estimated during the design phase. It helps to find the hot spot which may lead to the failure. Power is also dissipated due to glitching activity in a circuit. Glitches occur due to different delays through different parts of the circuit. So to accurately trade-off power versus other design parameters such as area, performance, and noise margin can be estimated in various levels: transistor level or circuit level, gate level, register transfer level, behavior level, software level. So the power can be estimated these 5 levels using two approaches: simulation based method and probabilistic based method. Here, if the block diagram is used to estimate the power in all the 5 levels. So this is nothing but a large number of input pattern, that is non-return 0, return 0, okay, bipolar return 0, non-bipolar return 0. The pattern may be in any form is given to the input of the circuit level. So many circuit simulation runs. This is circuit level simulator. It may be either as spice or the power band. Okay, the input is given and the power can be estimated by using either the spice or power band tool. It will generate large number of current waveforms. It will generate large number of current waveforms. Now we are going to calculate what will be the average power and the estimated power for the given circuit for the different types of inputs. The same thing, the next one, first the signal is given to the circuit. We are going to estimate each and every input, whether it is a static input or dynamic input. What is the probability of the input? That probability values are estimated. Now using this, it's going to be analyzed. That is, it has a LT times 2 density simulator tool, DENSIM. Using the tool, it's going to be analyzed, that is static probability, signal activity, transition density, transition state probability is the thing going to be uptime. From this, the power can be estimated. So this is simulation based approach. Transistor level simulation, switch level. In switch level, model transistor has a on-off switch with a resistor. Short circuit power can be accounted by observing the time in which the switches from a power ground part. Then that is, there is a short circuit exhibits between power and the ground that leads to short circuit power dissipation. Gate level simulation. Gate level simulation can be estimated uptime basic components, that is logic gate. The logic simulation to find switching activity, that is FS switching activity. Using this we can find it, or we can use Monte Carlo simulation method. So Monte Carlo simulation method is nothing but each sample has n random input vector. Energy consumption has a normal distribution. Stopping criteria derived from sample average and the sample standard deviation. So this is the method used for gate level simulation. RTL level simulation. This is basic components are registers, adder, multiplier, etc. Register transfer level simulation collect the input statistics of each module. So macro modeling of each component based on simulation. So the simulating the component with the random input. Fitting a multivariable regression curve using a least mean square error fit. Then high-level power prediction use profiling and simulation techniques to address data dependencies. Behavior levels estimation. No much register transfer level circuit structure information available. So this is total capacitance estimated based on output entropy. Average activity for each line approximated by 0.5 its entropy. So complexity based models equivalent gate. Then another one software level estimation. So the Monte Carlo power simulation is the one of the software level to estimate the power. So what it will happen means you look at the flow chart. Start generate random circuit state. Circuit state means 0, 0, 0, 1, 1, 0, 0, 0, 1. Depending upon the number of inputs, randomly the states are generated. What kind of circuit? Combinational or sequential? Okay, combinational means it will check it, run simulation for a warm-up period. If it is a simulation, because the sequential circuit, we have a present state. Based on the present state only, with the input, the next state will change. So for that, the warm-up period is needed for the sequential circuit. So depending upon the circuit, it will generate the input and the sample. So generate inputs A, comma B, P is the present state, is the input and the sample. Then it converge. Yes means we will get the output. If no, again random will be generated. Okay. Now we simulate the circuit. The estimated power dissipation of the circuit under simulation is given by the average value of the samples. We collect samples at a fixed interval to compute the sample mean. So P is equal to P0 plus P1 plus P2 till Pn divided by n, the sample variance S squared using the equation S squared is equal to 1 by capital N. Capital is number of samples. Summation of I equal to 1 to N Pi minus capital P is whole squared. So the Pi is nothing but the probability of each and every state. The variables capital P and S squared are the quantities that can be directly computed from the observed n samples of I. So given the confidence level 1 minus A and error tolerance epsilon, we check if the equation is satisfied. The quantity Tn minus 1 comma alpha by 2 is obtained from the T distribution function with n minus 1 degrees of freedom. So n is greater than or equal to Tn minus 1 alpha by 2 S divided by epsilon into P. If this n equal T must be satisfied. The stopping criteria have been achieved and the simulation process is called the Monte Carlo power simulation. The procedure is summarized as follows. Simulate to collect one sample, evaluate sample mean and variance. This is the formula. Check the inequality is satisfied to stop the criteria or not. So this is the way the power can be estimated, whether the combinational circuit is simulated or the sequential circuit is simulated. So this is the concept of Monte Carlo power simulation.